Yeah, good evening, everyone. How are you guys doing? Tonight, we'll be talking about Fourier series. We are going to solve one problem. So, let's look at Fourier series tonight. Uh, the Fourier series of f of x is defined in an interval Fourier series f of x is defined in an interval talking about let's say minus p comma p as f of x is equals to a naught all over what? All over 2 plus summation n equals to 1 to infinity, open bracket a naught times cos n pi x all over p because the interval plus b not sine n pi x all over p. So this is the definition as a is equals to 1 all over p integral the interval minus p to p f of x dx. Then our an is equals to 1 all over p integral minus p to p, then f of x times cos n pi x all over p dx, and bn is equals to 1 all over p integral minus p to p f of x times sine n pi x dx all over p. Are you following? Yeah. So this is how to define Fourier series. So do you have any question? Yes or no? No question. So let's proceed. There is no question. So let us move further to consider example. One example. Let's move further to consider example. Expand in this. So this is the definition of Fourier series. Okay, so let's proceed. Expand example. Expand f of x equals to 0, the interval is minus pi less than x less than 0, then pi minus x, comma, the interval of 0 less than or equals to x less than pi, right? So at first, we are going to consider a naught. Is that clear? We'll consider our a naught. So since the interval, according to the definition, the interval was minus p comma p, right? Yeah, but here the interval, we are talking about what? It means anywhere you see p, you just substitute in what? Pi. That is what you are going to do here. So far, so good. So what we need to do here is our A naught. Our A naught is equals to what? 1 all over what? Pi. Instead of integral, the first function, the interval, is minus pi to 0. So minus pi to 0, then the function here, our f of x is what? 0, right? Times, yeah, 0, isn't it? It is times dx, then plus the second function, integral, second functions, 0 to what? Pi. 0 to pi, look at it, the interval, 0 to pi. So the function here is what? Pi minus x times what? Dx. So let us first obtain our A naught. So all of this, because of this 0, the whole integral will be what? 0. So what we are going to consider first is this. So it means our A naught will now be integral 0 to pi, open bracket, pi minus x dx. So if we integrate this function, we are going to have, okay, let me just break it down. Integral 0 to pi, then pi times dx minus integral 0 to pi x dx. True or false? Yeah. You agree with me? True or false? It's true, right? True or false? It's true. Right? Okay. So let us proceed. Let's proceed. Let us proceed. Let's proceed. Okay. So if you can see what I am saying, it means our A naught will now be equals to, integrate pi dx. Let's just say, let's factor it out. Let me still break it down. Pi is a constant, so you factor it out, then dx minus integral 0 to pi x dx. So if you integrate dx, we are going to have x times pi. We are going to have pi x at what? At 0 to pi. Then what do we have here? Minus integrate x squared. We are going to have x squared all over 2 at 0 to pi. So what we need to do, our A naught will now be equals to, let's subtract the lower limit from the upper limit. So here we are going to have, anywhere we see x, we write pi. So pi times, this is x, right, times pi, then minus, anywhere we see x is 0, minus pi times 0, right? Okay, we're going to put it inside the brackets. So what we have here, minus, let me put it inside the brackets. Anywhere you see pi x, just write pi minus the lower limit. Pi minus the lower limit. Sorry for the break in transmission. Yeah, so here will be x. X, anyway, you see x, you write pi, but it is squared. So pi raised to the powers of 2, true or false, all over what? All over 2 minus, anywhere you see x, you write 0, 0 raised to the power 2, all over 2. Then this will give us 0, true or false. Look at the board very well, breaking it down so that you people can understand. Are you following? I'm breaking it down for you to know it better. Okay, so if you can see what I am saying here, pi times pi, our a naught will now be equals to pi squared. Then pi times 0 is 0, so pi squared minus 0 is pi. Then here already, here is what? 0. True or false? So you just use to multiply out, we are going to have pi squared all over 2. Then when you come across something like this, you look for the LCM, true or false. So the LCM is 2. This will now be equals to 2 divided 1, 2 times pi. 2 pi and pi squared is 2 pi squared. What do we have here? Minus 2 to 2, 1 times pi squared is pi squared, right? So 2 pi squared minus pi squared is pi squared, right? True or false? All over what? 2. But mind you, from the formula, this is how it's supposed to be. Yeah. 1 all over pi. So don't forget. Is that clear? Don't forget. So our a naught now equals to, from the formula here, this is what we got from here. True or false? Inside this bracket, this is the answer. So we must use it to multiply 1 all over pi. So 1 all over pi times pi squared all over 2, then this will be 1, then here is pi all over 2. So our final answer, a naught, is equals to pi all over 2. Do you agree with me? Yeah. So this is how we got pi all over 2. Is that clear? Yeah. So we will move further to consider, because we have to define when you have been given functions of this form, you have to define the Fourier series, because the definition contains a naught, true or false, a n and b n, isn't it? Yeah. So we have to go ahead to solve to obtain this. So I can now clean all of this. Then let's go ahead to consider a naught. Amen. Okay. A naught. A n. So let us consider a n. an is cos, right? Yeah. So here will be our an is equals to 1 all over pi. Two of us. Yeah, open bracket, integral the function minus pi to what? 0. So 0 times cos n pi x dx. Then, yeah, then plus integral. Here the function is what? Pi minus x times cos n pi x, right? Dx. Yeah, you can put it inside the brackets, no problem. So can you see now? So if you can see what I am saying, because of this 0, the whole of this integral will be 0, two of us. So our an 1 all over pi, is that clear? Will now be given as, but mind you, let me write down the answer of this pi all over 2, right? Okay, so if you can see what I'm saying, this will now be open bracket integral, the interval, I will not write the interval, 0 to what? 0 to pi, right? To pi. So 0 to pi, open bracket, pi minus x, open bracket, cos n pi x dx. Right? Okay. So now, when you come across functions of this form, what are you going to do? What will first come into your mind? Huh? I know very well that you were taught, excuse me, elementary calculus. So when you come across functions like this, you discover that we have two functions here, this and this. So that will make you to recall what is called integration by parts. True or false? Do you agree with me? Please look at the board. You agree with me, right? Okay. So if you agree with me, this implies that here we'll now write using by parts, right? Using by parts. And by parts, the definition is integral u is equals to uv minus integral v du. So you don't need a prophet to tell you. You just say let u be equals to this, the v be equals to this. So let's write let u be equals to pi minus x and the v be equals to cos n pi x. Right? Yeah. Hope I'm right. I think it's supposed to be nx, not pi x. It's supposed to be nx. Sorry. Dx. Nx. Cos nx dx. So please take note. Cos nx dx. So nx dx. Please, sorry for the mixed up. Okay. Excuse me. So here you are going to differentiate with respect to x. If you differentiate it, you have the 1 over dx. You are going to have minus 1. Then du, you have to obtain du. Du will now be, by the time you cross multiply, the x times minus 1 minus the x. And here you are going to integrate both sides, this and this. If you integrate the v, you are going to have v equals to, if you integrate cos n x dx, you are going to have minus 1 all over n sine nx. So we are going to substitute this into the integral. So this implies that our an, but mind you, we have 1 all over pi, right? Will now be equals to 1 all over pi. Then we now write open brackets. What is there? Ordinary u. Ordinary u is pi minus x, close bracket, times ordinary v is minus 1 all over n sine nx, nx at, since we are dealing with what? Interval 0 to what? 0 to pi. Then what we have here, minus integral, introduce the interval 0 to pi. Then what is our ordinary v? Our ordinary v is equals to minus 1 all over n sine nx. Then times what is du? Du is minus what? Dx, minus dx, two of us. So now, when we substitute in the interval here, by the time we put pi here, okay, I will break it down. N equals to 1 all over pi, open bracket, pi minus pi. Anyway, you see x, write pi. Then minus 1 all over n sine, anyway, see sine pi, right? Yeah, minus 0, right? Minus open bracket, you substitute in the value of 0. Anyway, you see x, right? 0, open bracket, minus 1 all over n sine n, open bracket, 0. Then minus times minus plus, so minus integral 0 to what? Pi. But let's do one thing. 1 all over n is a constant, so we can just write it outside. Then we now write sine n nx dx. Do you agree with me? Amen? Do you agree with me? It's okay. So if you agree with me, let us proceed. Let's proceed. So whole of this will be 0. Because sine 0 is 0 times this 0. Then pi minus pi, 0, 0 times this 0. So our an is equals to 1 all over pi. Then here will be what? Minus, right? Minus 1 all over n. Let's integrate minus 1 all over n. Then when we integrate sine nx dx, we are going to have 1 all over n, right? Cos nx at 0 to what? 0 to pi. Then this will be equals to, by the time we use this to multiply this, and already here will be what? 1, right? Yeah. So far so good. So here will be, let's multiply it out. Use this to multiply, then multiply this one. We are going to have 1 all over n square pi, right? Then open bracket cos n x at 0 to what? Pi, right? True or false? It's true, right? Okay, so let's proceed. I can clean this, right? Okay. So far, so good. If you can see what I'm saying, you don't need the prophets to tell you. By the time we substitute in this, we are going to have, here will be what? Here will be 1 all over n square pi, and open bracket cos n pi minus cos what? Cos n 0, right? Yeah. Subtract the lower limit from the upper limit. So if you can see what I'm saying, I want us to note that cos n pi is equals to minus 1 raised to the power of n. Yeah. But wait, we want to forget something. Here is supposed to be minus. True or false? Here is supposed to be minus. So we are supposed to have minus sign here. Alright? True or false? Then cos this is what? Cos 0 is 1. True or false? So minus 1 all over n squared pi, open bracket, minus 1 raised to the power of n minus 1, right? So if you can see what I'm saying, our an is equals to, if we use this to multiply this, this is how it will be, minus 1, here will be minus raised to the power n all over n squared pi, minus times minus is plus, so plus 1 all over n squared pi. Do you agree with me? So this implies that we can rewrite this in this form. This is the same thing as 1 minus, open bracket, minus what? 1 raised to the power of n all over the LCM is what? N squared what? Pi. True or false? Yeah. So this is what we are supposed to get for an. So you understand how not clear. I'm just trying to, no, that is how it is, as long as Fourier series is concerned. Cos n pi is always equals to minus 1 all in bracket raised to the power of n. So take note, it's something you're supposed to put it there. Then this negative sign, we got it from here. Here is negative. Use this to multiply. You have 1 all over, minus 1 all over n squared, true or false, times this pi. So yeah, so far so good. So let us move further to consider what is it called? To consider Bn, right? So let me write the answer an answer here. Our an answer is equals to 1 minus open bracket minus 1 raised to the power of n all over n square pi, right? So let's move further to consider Bn, as simple as ABC. Oh, the function, I think we can remember, right? Okay, so Bn is the same approach. Exactly. So our Bn is equals to 1 all over pi, open bracket, integral, you know the function, minus pi to 0, right? The function is what? 0 times sine nx dx, isn't it? Then plus the other function is what? 0 to pi, right? Then is pi minus x times sine nx dx. True or false? Yeah. The b is sine, right? This is odd, right? It's okay. So now what we need to do here is, because of this 0 multiply this integral, here will be 0. So our Bn is equals to 1 all over pi, open brackets, we only consider this integral, amen, integral pi minus x times sine nx dx, right? Okay. Yeah. So far, so good. So far, so good. So, you know, I asked a question before, but I said when you come across functions of this form, what will first come into your mind? If you have to integrate this function, we'll use what is called what? Integration by parts, right? So now we'll now see, using by parts, right? Okay. So if we use by parts, this implies that by parts is always integral u dv is equals to uv minus integral v du. So we now say let u be equals to pi minus x, what we did to an, and let's differentiate this. Our du all over dx is equals to minus 1. Then by the time we cross multiply, our du will now be equals to minus dx. Then let the v be equals to sine nx dx. So if you integrate this, you are going to, if you integrate the v, you have v. Then if you integrate sine nx dx, you are going to have 1 all over n cos nx. So you just need to substitute in here. Then let us not forget 1 all over pi. 1 all over pi, open bracket, now introduce this, right? What is our ordinary u? Huh? What is our ordinary u? Our ordinary u is pi minus x. Then yeah, Then our ordinary v is times 1 all over n cos nx at, because the interval, don't forget the interval, 0 to what? Pi, right? 0 to pi. Then what do you have? Minus integral 0 to pi. What is our ordinary v? Is 1 all over n times cos nx. Then what is our du? Du here is what? Minus dx. Minus dx, right? So if you use this minus to multiply this minus, here will be what? As you can see, if we substitute in 0 here, we are going to have, let's substitute in, our bn is equals to, is that clear? I'll break it down for you. We are almost done. So here will be t minus, anyway you see x, we write, sorry, pi times 1 all over n cos n pi, right? Anyway you see. Then minus pi minus what? 0, right? Then times 1 all over n times cos n open bracket 0, right? Then minus integral, this times this is going to be plus. So we are going to factor out this 1 all over n plus 1 all over n integral 0 to pi, right? So here will be cos n x dx. True or false? So far so good. Here pi minus pi is 0 times this is 0. Then pi minus 0 pi cos 0 is 1, right? So I think if you can see what I am saying, bn is equals to 1 all over pi. You can see what I am saying. Here will be n times 1 all over pi times 1 all over, but there is minus. So minus pi all over n, then plus 1 all over n, right? Let us integrate this. When we integrate cos n x dx, we are going to have minus 1 all over n sine n x at 0 to what? Pi. This is what we are supposed to have. True or false? True or false? It's true, right? It is true, right? It's okay. So let's proceed further to look at it together. Okay? Let's proceed further. It's okay. So far, so good. Okay, I can clean this and clean the hub. Okay. So if you can see what I am saying, you don't need the prophet to tell you our bn is equals to let's take the limit, the interval. Is that clear? So here will be 1 all over pi, open bracket, open brackets. Let's factor this one out. This one times this, here will be minus, but we have minus pi all over n, right? Then this time this minus 1 all over n squared then open brackets. Let's subtract. Here will be sine n pi, right? Then minus sine n0. True or false? Am I communicating? Yeah. Okay. So far, so good. So here will be 0, right? So let's proceed. Our Bn now be equals to if n is 0, if n is 1, so will now be equals to, I use this to multiply out, we are going to have minus pi all over n, right? Then this time this minus 1 all over n square pi, right? Okay, so let's take the LCM. The LCM is going to be n square pi, right? This n times minus n pi square, right? Hope I'm right. Then this minus this times this is going to be 1. Am I correct? Hope I'm right. I think here is supposed to be 0. Sorry. Here is supposed to be 0. Why n is 0 sine 0 times this. So we are supposed to have 1 all over pi times minus pi all over n, right? So of course, look at the board. So when you multiply, you are going to have this to cancel this. You're going to have minus what? 1 all over n. So I think our b is minus 1 all over n, right? So far so good. So what we need to do here is I think it's supposed to be plus or minus coming. We got this from here. Okay, let's continue. So our f of x now be equals to our a naught is, let's write it down again, a naught all over what? 2, right? Plus summation n to what? 1, n equals 1 to, then we are going to write an, right? An cos n x, right? Plus bn sine n x, right? Close the brackets, right? If I'm not mistaken. Yeah. True or false? It's true, right? Okay. So our f of x now, because what is our a naught? A naught is pi all over 2, then divide these two, plus, I'm going to break it down now, n equals to 1 to infinity. What is our an? Our an is this, right? So here will be 1 minus, open bracket, minus 1 raised to the powers of n all over n squared pi times cos nx, then plus here plus minus 1 all over n of b n. Bn is this, right? Times sine nx. So far, so good. So our final answer, I know very well that since it's odd negative, so here is supposed to be what? Plus 2. Yeah. So here will be f of x is equals to, in algebra, when you have pi all over 2 divide 2, which is the same thing as pi all over 2 times what? 1 all over 2. So pi times 1, pi. 2 times 2, 4. You are going to have pi all over what? 4 plus summation n equals to 1 to infinity, then 1 minus, open bracket, minus raised to power n all over n squared, then cos nx, here will be plus, go and find that, plus 1 all over n sine nx. This is what you are supposed to have. Is that clear? So, gentlemen and ladies, I want to appreciate you for your time. I love you guys. Please don't joke with this solving. This video is very important during your exam. Thank you and God bless you. Love you guys. Bye. Where are you watching from? Sergeant Kuma, 1945. Which country? Kuma, which country are you watching from? UK. Oh, that is nice. Nice meeting you. Yeah, I will drop my WhatsApp number, then we communicate. Is that clear? Here is my WhatsApp number, so that we communicate. Plus 234 703366 7737. Kuma, I hope you enjoy the class. Oh, thanks. Thank you very much for your comments. But I'm still learning. Colin Stamo, which country are you watching from? That is my number. You can reach out to me on WhatsApp. Oh, I just finished solving Fourier series. Yeah, what level are you? Kuma. Kuma, what level are you? I know very well that you will soon get to this high level mathematics. And what are you studying? Year 1 level mathematics, okay? Are you studying mathematics or engineering? Are you a mathematician? Kuma. Kuma, that is my number. You can chat me up so that we talk. Oh, chemical engineering, that is nice. I think you will do all these things. Your year 2, level 2, you do Fourier series. Level 2, year 2, year 3, you do Fourier series, chemical engineering. You do Fourier series, so you can reach out to me in case you have any mathematical challenge. You can chat me up. We talk so that I will be live here and teach you how to solve mathematics, if you don't mind. Is that clear, Kuma? I would love to have your number. So chat me up so that we'll be communicating every now and then. Yeah, but get my number there so that we talk. Is that clear? But help me recommend students to this channel, please. Kuma, your coursemate, your classmates, help me recommend them to this channel in the UK so that they will be part of. Help me recommend them to this channel. Please do that today. I will be very grateful. I will be very grateful. Do that today. Recommend the channel to them. I'll be very grateful. Yeah, I would love that. If your friends would like my channel, I would love that. If you can convince them, tell them to subscribe to the channel, and they should also recommend the channel to their friends, loved ones in the UK. I'll be very grateful if you can do that. If you can do that, I think it will be better we chat on WhatsApp so that please we'll get to know each other. Time goes on. You do AQA, A-level mathematics, okay? No problem. What you do, just snap and forward it to my WhatsApp. My number is there, +2347033667737. Okay, no problem. Just snap the mathematics, then forward it to my WhatsApp. I will look at it, then I'll solve it here. I'll be live here, we'll communicate. Nice meeting you. Yeah. Good night. Thank you. Rest well. Bye.